feels like a gift, really, every day to get to be here. The whole goal of the cruise, the point of being here, is to understand how this beautiful place is being affected by climate change. So there's 3 teams here. One is from Oregon State University, and we're studying late season productivity, which is the bottom of the food chain. There's another team here from Virginia Institute of Marine Science, and they're also studying productivity, but a special kind called nitrogen fixation. And the third team is from University of Alaska Fairbanks, and it's a team of 1. She's here to do a test deployment on a glider with a special sensor on it.
We're studying the carbonate chemistry of Arctic Ocean waters in the context of oxygen production and nutrient utilization by phytoplankton.
We are in a project that's designed to understand how productive these waters are later in the season. And by later in the season, I mean September, so after the summer.
We're up in the Chukchi and Beaufort Seas off of Alaska in the Arctic Ocean, and we're collecting water samples to look for nitrogen fixation, who's doing it, which microbes are doing it, how fast they're doing it, and where they're doing it.
The big thing with climate change is that we're taking CO2 in the ground, we're putting it in the atmosphere, and it's warming everything up. So what would be really great is in the Arctic Ocean, if organisms in the Arctic took up that CO2 and removed it from the atmosphere. But they can't do that unless they have enough nitrogen.
So we're getting water samples from the surface, utilizing the surface seawater that comes into the ship as we motor along our cruise track. Some discrete depths where we can do a little bit closer examination from the CTD. We're also taking cores of, and we're grabbing surface sediment from the ocean floor. And finally, we have a somewhat novel method, and we call it the super sucker. And that is a sled that we tow in the water column. So we have a really well-balanced suite of sampling.
Once we get on station, we put a CTD over, we collect a water sample, we quickly put those in bottles, add nitrogen gas. We incubate that in incubators in the back deck, and there's water flowing through to keep them at the right light level and temperature.
We've found actually a lot more productivity than you would expect for this time of year. And that's pretty important because if it persists, if this is a normal thing for this time of year now, it represents a pretty fundamental shift in how things work up here. We also have a pretty great educational component to this cruise. We have undergrads on board. We have graduate students that are doing their own research. And we also have a 6th grade teacher who is communicating with her classroom about all the great science that's being done out here. None of this would be possible without the amazing crew on the Sikuliaq. They have kept us fed, gotten us to where we needed to go, and facilitated science in every conceivable way possible. In addition to that, they're just great people, so it's been a lot of fun to be out here with them. We've been deploying moorings, retrieving them, putting boats in and out of the water, deploying really expensive equipment to the seafloor and getting it back again. And it requires a team that knows exactly what they're doing, and this ship certainly has it. I'm grateful to Oregon State University and NSF for making this research possible.
I'd like to thank the Alaskan Eskimo Whaling Commission for working with us and seeing the importance of our work and how it fits into the world that you guys have been living in for so long.
The successes of this cruise are one piece of a larger puzzle that will help us understand how the Arctic will continue to change.